afternoon to all of you. Welcome to this webinar series at Faculty of Management Studies. Myself, Dr. Rachel Javedi. Just I would like to introduce about today's webinar on Sustainable HR Practices, Industry 4, part of Smart Cities. It would be a great privilege to introduce for today's expert, Professor Dr. Sudans Jha, Professor, Chandigarh University, Punjab. It would be a great learning opportunity. Those who want to make their career in area of entrepreneurship, those who want to make a career in area of HR or IT, because sir is having a diverse knowledge in area of entrepreneurship, research and development with specialization in Internet of Things, artificial intelligence, nutrosoptic soft cells. He is a senior IEEE member. He is currently working as a professor at Department of Computer Science and Engineering, Chandigarh University, Punjab, India. He received his PhD degree in 2015, received his graduation in engineering from MNREC College, Allahabad, 2001. He has around 75 accepted and published research paper and book chapters in reputed SCI, SCIE, ESCI, Scopus Index journals. He is editor in international journal published in South Korea. Additionally, he has edited 6 books for some of the top publishers like Elsevier, CRC, and Apple Academic Press. He has served the research field as a faculty resource person, session chair, reviewer, TPC member in various conferences and journals. He has delivered keynote speeches in several noted international conferences. Also served as a technical director in Nepal's National Broadcasting Media, Nepal Television. He also served as a standing individual consultant of Nepal's telecommunication regulatory body, Nepal Telecom Authority. He has served various national and international institutions as principal HOD and director in engineering college and technical universities. Really, it would be a great learning opportunity to all management students. Special thankful to Sapna Madam, who is coordinating for today's program as a moderator, and Vivek sir, who has also invited such a great personality. Thank you so much for sparing very valuable time at Faculty of Management Studies. I would like to hand over this platform to you, sir. You can share your expertise with our students. Thank you so much.
Thank you, ma'am. Thank you so much. And hello and good afternoon to everyone, one and all present over there. From the last 1.5 years, we have been going through the turbulence of, as you all are aware, and we have to bound to go to this digital platform. A lot of have been changed in our day-to-day life, learning methodologies, teaching methodologies and all. And you all agree with that currently the second wave has been so notorious that, in fact, it's very dangerous. And first, before starting my talk, I would like to request all of you to take care of your health very, very carefully, because recently I had gone to that phase and I just got, bach gaya kind of thing. So it's my humble request to all of you to take care of yourself, and by taking care of yourself, you'll be taking care of your family. Secondly, I would like to thank Parul University, our Dean ma'am, especially Sapna ma'am, who have been so active and spontaneous, responding so spontaneously. Vivek, who have been my scholar long back, a decade back, to invite me in this webinar. And today I'll be delivering on Industry 4.0 with its correlation with the smart technologies. So basically, as I have been said, that my audience will be from MBA management streams. So I will be focusing on technology blended with managerial point of view. So please, you can raise your issues if you have any in between the session. It's heartily welcome. But what I believe is that this gathering will help you to provide, which I expect is that the communications and research developments along with the management should go blendedly. And these ideas and experience which we will be sharing out here, I hope it will motivate you towards smart technology, because I am a man in smart technology. I have been working in there, and the outcomes that is coming out from this talk will be helpful to you. Thank you all. So by saying this, I would like to start my presentation. I hope my screen is visible to you all.
Yes, sir, it's visible.
Yeah. So let us start with the very basic definition of the Internet of Things. So what we do, we are talking about, we all are wearable, we all have been used to with the wearable devices. Now, what do you mean by wearable devices? The devices that we say that the smart devices, from your mobile, from your headphones, from your watch, and from appliances, wherever we go around, we are surrounded by smart devices, isn't it? So the core part of the story is that we have to understand what actually is smartness. How can we say that a particular device is smart? So from the figure, you can see that there are lots of components, I should say, that are involved in our day-to-day life. And in technology, we say that these all are specific objects with specific tasks. Now, the interconnection of these all type of objects have been done from last 4 generations. First generation, second generation, third. We are right now in the 4th generation. So there are so many things that have been done from the decades, years of back. Today, when we talk about the interconnection of these objects, which is now called as things, is Internet of Things. Now, the difference between the previous interconnection and the current interconnection is that they should be connected via internet, and there should be a physical mode of data communication between these devices. Now, from the figure, you can see that how a lock can communicate with a bulb. Now, that is a question. Now, that kind of questions are being resolved, and we say that now the technology has become a smart technology. Fine. Similarly, you have car over there, then you have a truck over there, then you have mouse. Now, it's obvious and everyone can understand that now car and mouse can be connected. But how a key and an aeroplane can be connected? Now, that connect, then we say that it's a smart technology. For that, we have to understand what is IoT. So I'll just go with basics of IoT. It describes the network of physical objects, which are called things, that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. And that is our point of concern when we talk about smart technology. This has already been understood. We all are doing this. We all are using smart devices. So nothing much has to be discussed over there. Now, the issues in these smart devices is that they are not still secured. There are still so many issues related with the connecting devices. The connecting issues may come due to so many weather calamities, so many natural calamities and all. Apart from that, there is no as such 100% safety assured. And since safety is not assured, the automation is not there. Full automation is not there. So that is the second issue. Third one, when we talk about reliable connection, how the government is going to give you the reliable connection? What is the guarantee that you are getting 1 Gbps of data that has been assured to you, and you are getting 1 Gbps of data, maybe 100 KB of data or 200 KB, whatever is there. So these are the issues that are coming out despite of having so many smart devices. Fine. And the last one is, this is what I'm going to talk about, the taxonomy model for Industry 4.0 as a part of smart cities as an example. So there are so many examples to be discussed. You can consider your phone as a smartphone. You can take your home as a smart home. Even today, kitchens are smart kitchens, right? So everywhere, everything, biometric devices are smart devices. But here we will talk talking about smart cities with reference to Industry 4.0 with reference to smart cities. The smart city is a place where traditional networks and services are made more efficient, and the use of digital and telecommunication technology for the benefits of inhabitants and business. How do we define a browser? You log in, you are being provided with the credentials, and then you log in into an environment. Let us say you have logged in into the very commonly used app called Zomato. You want to order the food. So you have a single click. You go on to the buying and food or whatever has become a smart kind of thing. Now this has changed from traditional networks, traditional process to
Sir, are you there, sir?
Yes, ma'am. There was suddenly disconnected. I think it's visible now.
Sir, the presentation is not visible. So can you share it again?
Is it visible now? I think it's visible.
Yes, sir. Yes, sir. It's visible.
Thank you, ma'am. Okay, I'm sorry for the disruption. So the main reasons for the emergence of these type of smart technology has resulted into the comfortability of human well-being. It has been given a huge benefits of the inhabitants, and topmost it has become a business nowadays. There are a lot of AI trainings going on. I will show you on some of the videos that I have collected. And the AI itself, artificial intelligence, has become a business. So who can give you the faster, smarter services? That has become a race paradigm today, right? So this is now, from the startup companies. You all are MBA graduates, or going to be MBA graduates. You will have managerial skills that has to be blended with. Maybe some of you will be going to opt out the technical subjects in the upcoming semesters or in the future studies, but somehow you have to be in touch with these technologies and managing the services of these technologies, how they are being incorporated in your corporate houses or companies and all. So coming down to the second point, what I would like to elaborate is that the main reasons for the emergence of the smart technology, here I'm specifying with the smart city, is that it is to create a sustainable model for cities and preserve quality of life of the citizens. And what is quality of life of citizens, and what is preserving quality of their life? We have to understand why it is required. So based on evolution of technologies, there were so many advancements. Previously, we had digital transformation. Before that, we had machine transformations. And before that, it was a conventional approaches. Today, we are in a digital transformations along with communication technologies and sensor-based technologies. Now, apart from that, we also are moving from evolution of technology to the highly competitive markets. The customers are demanding the high qualitative devices. Let us talk about devices. The producers, the companies are targeting for the high quality demand that customers are expecting. So every day you are getting new models, every day you are getting new versions, every day you are getting new versions of appliances and all. Now this has ultimately resulted into the high amount of production within minimum timeline. Now by saying this means that they are not at all. I'm not saying to each and every companies, but the quality assessment has not been properly done when there is a high amount of productions within minimum timelines. I hope you all agree with that, because you have to produce, the customer's demand has to be fulfilled, and the producer consumer problem has to be resolved. So producers are running behind the production of the products. Very less time is there for them to test the systems, right? So there we come into the point which is called the risk of failure. Now, this smart technologies inculcates these all points, and it has now the resolutions. It comes with the reduced risk of failures. It also inculcates high amount of productions with minimum timelines in such a way, like artificial intelligence, the IoT, even we are talking about industrial IoTs. Advantages of smart technologies. So it reduces cost. Yes, ma'am.
So the presentation is stuck at one slide. I think you have moved down to slide number 5, it seems. It shows slide number 3.
Yes, ma'am. I think I'm in slide number 3 right now.
Okay.
Shall I continue?
Sure, sir, sure.
So this was what I had discussed right now, and this is slide number 5. So in short, these all reduces cost, increase efficiency, improve quality, improving predictability, improving safety. These all you can correlate with whatever smart device you are having right now in your pocket or at your home. You can just check how it has reduced your cost, how it has increased the efficiency in terms of your time, efficiency in terms of accurate results, efficiency in terms of your working performance, and so many appraisal systems you can correlate with. It also has improved quality of standard living, quality of communications, quality of learning things, quality of adaptability. So these all parameters come into the picture when we are talking about smart technologies. Now it has improved predictability. So this is something called, we talk about machine learning. When we are talking about machine learning, we use a huge data sets. We take the huge data sets, apply them to a particular algorithms, and we try to get the results. Something like weather forecasting or stock market trending and all. So this has also improved a lot in smart technologies. And the last one is that it has helped us in improving safety. So the best answer to this is the biometric thumb impression that you are going to punch when you are entering inside the university, or you're logging into the banking system, banking house, wherever it's applicable. From that to two-way authentication, and then the sensor grid communications or smart grid communications. So improvement have been done so far in terms of safety. Now coming to the components of smart city, you can see this is the smart city that we are talking about. Yet I have not entered into the smart city literally. But if you talk about smart city here, what we can see is that it has several components, like smart environment. Smart environment is something like, you have pollution alert, you have rain alert, or whatever is there related with environment. So that alert is there, and you will be notified in a due course of time, or you will be warned that something wrong is going to happen. You take care of yourself. We have smart economy, smart governance. Today we define this as e-governance and m-governance, electronic governance or mobile governance, right? So then we have smart people, then smart living. Now, smart living relates with the smart kitchen, smart appliances and all. So these are the first layer of components that are associated with your smart city. Now, if you come out of this one, you can see that there are 4 different paradigms that are encircling these components of smart city. I will start with Internet of Things, so which we have already discussed. It's a physical connection of different things, or also called as objects. We have Internet services. Now, what is that Internet of Services? When you try to access a particular service through your smart device, and that service is not directly available with that. Let us talk about a particular app. You are going to purchase a product on Amazon. You selected the product is available to you, but Amazon is not the right platform to take your money online directly. So what it does is it redirects your transaction, your event or your whatever session you have to the gateway of the bank you have chosen. Easy. To the very to be very literal, you are at Amazon right now, and what you are doing is you have purchased a product, and when you try to pay, the Amazon will stick over there and it will redirect you to the bank where you have chosen to pay. Now this is something called gateway, right? So what I mean to say is that the service is I'm sorry, the service is Amazon. The Amazon is availing the other service for the payment to your bank. You have paid your amount for the product to the bank and net banking, let us assume. It reverts back to Amazon with an acknowledgement saying that yes, this client has paid this much of amount. Then Amazon confirms you that your product is being confirmed. Now, what do you understand? What do we understand by this is that there are two services, broadly, if I should say, there are two services that are being interlinked. So this is something called Internet of Services. So Internet of Services is there, Internet of Things is there, then Internet of Data. So your sole data is not only necessary or will not be only applicable for different domains. Sometimes your data is interconnected with so many data that it becomes Internet of Data. Now, as an example, when you come out with your Aadhaar card number. So for particularly in my case, recently 1 or 2 weeks back when I had a test, so it was negative by the sake of God. But see how many data are connected with that Aadhaar card. So my name is there, my date of birth is there, this is fine. But apart from that, my bank transactions, my driving license, my job, my whatever I do, including the COVID test results is also linked with that Aadhaar card. So the number is one, unique, but it's itself is an Internet of Data connected with so many different structures and types of data. Fine. Then we have finally Internet of People. This is also a very simple example. So now this Internet of People, Internet of Things, Internet of Services, and Internet of Data, this as a whole is going to bound these all components of smart city and make a single smart city, a city, smart. So this is how it has to be explained. So this is the smart city concept. Now that was a model of smart city, right? What we have done. So if you go back and have a look, a brief history on the smart city, what we have seen is that several initiatives all over the world have been launched to transform towns or cities from scratch to smart cities. Of course, even in India, you can see this data. 100 smart cities were planned in May 2014. In South Korea, they had initiated 47 ubiquitous city, more than smartness, projects in May 2013. But this is what we conclude. In the recent works, they have concluded that no city has fully become a smart city. We say that Delhi is smart city. We say that Bhubaneswar is the smart city. But to some extent, they can be smart. But no city in the world has become a completely smart. Now, what may be the reason? What is the reason then? Even among the audience who are listening to me, if I ask you that, do you have a smart device? Of course, 99.99% of you will be saying that, yes, I have the smart device. But on the second hand, if I ask you that, is your device smartest one? Then there is no as such specific parameters to judge that your device is smartest enough. It's the smartest device. Now coming back to the previous slide once again. See, you have so many different cities throughout the world, throughout the globe, and there are lots of data that we extract from those cities. Now, the nature of this data and the optimizations we perform on this data varies from territory to territory. The data that we gather from Delhi and the data we gather from some other, I hope you understand, you're following me. So the data are same. It's all. If I talk about gender, it's male and female. If I talk about age, of course, it is from 1 to 100 or 110. If I talk about the other correlated data, they also are same. But the outcome coming from the optimizing of those data are different from training territory to territory. Now, since the data are different, the smartness varies, right? And since the smartness varies, we can't compare the smartness in terms of data. And the core part of smart technology is data. That's why we consider that data is, MBA students who have just entered, please listen to me carefully. Data is a fuel. Data is a fuel. I'm sorry, I'm a very bad handwriter, but data is a fuel. Why data is a fuel? Because it is the core part, or it is the raw material, what we say, for the entire technologies that are happening today and that are going to happen tomorrow. So now the trending will be a manager on data science, a manager on data analytics, a manager on data handling, a manager on data processing. These are the issues that are coming out to be the challenges in the future, both in terms of academic institutions as well as the corporate industries. Let us take an example to satisfy my previous statement. Smart cities around the world are diverse in their characteristics. In many terms, they are diverse. The information we have like, see, you wake up 5:30, 6, 7, 7:30, whatever your timing is, and until and unless you go back to the bed for the final time, you just imagine how many times you have exchanged the data from various Google Forms, through mails, through SMS, through WhatsApp, through messengers and all. How many data you have exchanged unanimously, right? In some of the cases, you solely believe that they are trusted sites and you know how to exchange the informations. And in some of the cases, we don't care because we are used to in such a way that we don't cross-check every time, and we keep on exchanging the data through those portals, through those gateways, through those platforms, right? But there is no as such 100% guarantee that those informations are going to get secured. That's why everyone is, it's a frequent news coming up into the news channels that somehow the data has been hacked, or the data has been stolen, or is being unethically accessed, kind of things. And if now previously the scenario is different, today the scenario is different in this way. Let me take you the statement. People are not secure if their data is not secured. I repeat, people are not said to be secured. I am not secure if my data is not secured, right? So these are the challenges. Then, since networks are believed to be the least secure parts of the system, cities must ensure that the networks are safe before embarking on smart city initiatives. That means that proper regulatory policies are to be required. The last one is everyone is needed online and needs to be able to access services in order to realize the full benefits of IoT.
So I think there is a lot of a voice breaking happening at your end. I think other students also are they able to hear sir clearly, or is it the same thing?
Yeah, please let me know, because I'm inside the closed room. Okay, just a second.
Fine, sir. So you can. Yes.
Am I audible, ma'am? Now? Am I audible?
Yes, sir, very clearly. I think the students are able to hear you. Might be it's at my end. Maybe I am not
Yeah.
able to hear clearly. So you can
No,
continue,
sure.
sir.
Yeah, thank you, ma'am. Let us continue with that. So, uh, I would like to moderate this statement because I mentioned the COVID, the turbulence, and all. So today we have habituated in our day-to-day lifestyle has been changed in such a way that everything has gone virtual. There's nothing real mode. The second wave is so dangerous that now government has forcefully put up everything onto the virtual mode. Even chief ministers are working from on a virtual mode. Now my point here is the smartness, working on smart technologies, managing them has become one of the biggest challenges for the entrepreneurs, academicians, and industries. So that is what is the challenge today. It's coming out from smart technology. So this we have already discussed, and this is just an exemplify of that component. That was a theoretical model, and this is the practical model or overview of a smart city. So you have mobility Wi-Fi, smart digital citizens, smart transportation, Mobus. In some of the states, there are Mobus running, mobile buses, right? And there is smart security, like surveillance camera and all. Then you have smart home. That smart home consists of smart lock, smart windows, smart kitchens, smart appliances, and all. And there are some open data, right? Because these open data are very much important. The reason is that they are related with each and every smart components that belongs to your smart city. We have so many apps that helps you out from the mobile itself, that reduces your calories, that helps you keep fit and fine, provided you follow their guidelines. Right? You don't have to physically go and meet the person, doctor. Smart buildings are there. So this is the overview of smart city. Now let's come back to Industry 4.0. I don't know how many of you have heard about this Industry 4.0, but it's the upcoming technology that is on a very high gear. Internet of Things is used for the development of so-called smart products. Subcomponents of the product are equipped with their own intelligence. Now, I would like to focus on this intelligence with these smart products. When can we say that a product is a smart product? Why do you say that your phone is a smartphone? A normal phone can also perform send and receive calls, send and receive messages. Right? So what is the difference, or what does it make the device intelligent? When we say that the person standing in front of me is an intelligent person, one of the factors is the decision-making process. The input that has been given to him, he applies that input into his neural system, and he comes out with a decision, which that decision is more intelligent than any other decisions available to me. Similarly, when we talk about devices, of course they are smart devices, smart products, but it is the intelligence of those devices that counts. And today, the race of adding this intelligence into the products is skying. I'm sorry. So you put on, this is your product, and you keep on adding intelligent services to this product, and this process has been exponentially increasing. And it is giving out the output, that is fine. But to some extent, at one point of time, we are going to face the saturation. And once we get the saturation phase, we feel that It's enough. Come to the next point. Come to the next technology. Again, this Industry 4.0 I will show you one of the example, provided you all are following these all points. So we have Internet of Services, we have Internet of Energy. Now, what is this Internet of Services? I have already explained to you. A services that is connected to the other services, and there are integration of two or more than two such services. I hope some of you may have the idea may be coming in your mind where two or more than two services are integrated with each other. Similarly, we have Internet of Energy. We talk about renewable and non-renewable energies, right? So one of the very basic example I would like to give over you is that piezoelectricity methodology. I don't know whether you all are in MBA streams, management streams, but let me give you an example. Suppose you have a sensor on your head. You ride a motorbike. You ride a motorbike and you travel on an average 60 kilometers per day. Number one. You have another sensor in your body which measures your heat. Let me repeat. You have one sensor on your helmet, and you travel 60 kilometers on an average with a speed of 60 kilometers per hour. Sorry, on an average 60 kilometers at the speed of 60 or 80 kilometers per hour. Now, the second one is the heat sensor that is deployed on your body that calculates and extracts the amount of energy, heat energy, that has been coming out of your body. Now, I will apply the third sensor on your, shoes, because you walk, let us say, 20,000 steps per day. Just a haphazard example. Why I have given these three sensors, why I am explaining these 3 points is that the first one, when you ride a motorbike for 60 kilometers, you are facing with the air pressure. Now, the sensor designated on your helmet is designed in such a way that it extracts all those pressures, mechanical pressures, and converts them into the electrical energy. Number one. Number two, when you are working day and night, a lot of heat energy is coming out from your body. The sensor will it will capture all those heat energy, and through certain piezoelectricity methodology, it will convert those heat energy into electrical energy. Coming down to your feet, I said you are walking 20,000 steps per day, 30,000 steps per day. On the basis of that, you are putting your mechanical force onto the ground. Now, that mechanical force that you're putting onto the ground, that is also creating a mechanical force. And we have so many processes to convert those mechanical process into the electrical energy. Now, from top to bottom, your body is generating certain amount of electrical energy. And you can refer to one of my paper, which I have mentioned in the last slides. These all energies can be gathered, accumulated, and converted into the electrical energy. And the resulting electric energy is sufficient to recharge your mobile with more than 30% consumption of the normal electricity rate. Now, what do you mean by that? If I plug in my mobile to the AC, the alternating current charger, maybe it will take half an hour to fully charge the mobile, but somehow I'm paying 1 paisa, 2 paisa, 10 paisa for that half an hour charging of my mobile. But the methodology that I have explained to you is really smart enough to give you a use of unpaid energy that has been created by your own body, right? So Industry 4.0 focuses on those type of Internet of Services or Internet of Energy. That is what we are going to talk about. That has been incorporated into the Industry 4.0. So here it is clearly written over here. So it determines the natural resources that are used in a proper way. That may be electricity, water, oil, which is known to everyone. And the example that I have given to you, it's a very genuine example, and this can be applied based on your critical thinking. You can apply at your home also, right? So these are the 6 principles that you can see. Just a second. So there are 6 principles of Industry 4.0, as you can see on the slide. They are interoperability, then we have virtualization, we have decentralization. So these all have their literal meaning with Industry 4.0. And how you correlate this with the smart technology, let me explain in short. We have cyber physical systems all over the world. In India, it's used, it's been talked about in large scale. So the ability of cyber physical systems, the humans, Industry 4.0 factories to connect and communicate with each other via Internet of Things and Internet of Services, that is what we call interoperability. If that would not be there, then sooner or later, the human interventions will be zero. Because everything will be done by machine and will be done for machine. Where are we going to exist? Do you think that our existence, what we are today, don't you feel that our existence or identification is degrading because of these smart technologies? No more, just leave everything. In this last 1 year, I have not seen anyone students face physically in real mode. I have never interacted them in person. Right. So similarly, when you are talking about the AI products, smart products, there are very less human interventions. The human interventions have decreasing down exponentially. Now that is not what we require. We require our interventions. We require our decision-making process to be applied. We require our authenticity to be applied. So interoperability has to be there. Virtualization has to be there. Decentralization, called blockchain, that has to be there. Real-time capability has to be there. The decentralization means the ability of the systems to make decisions by their own, approved by us, right? So these are the things that you have to take care of in the Industry 4.0. I think there is a net issue. Yeah. So after talking all these 13 slides, I would like to request all of you to clearly and sensibly watch this video, which has been taken from Boston Dynamics. Is the video visible to you all, ma'am?
So are you playing? No, sir. We can see the presentation, but the video is not. Maybe you need to change the tabs here. Again, you need to go to the present now option and check on the tab for video.
The video itself is there in the presentation. I think it should be visible.
It was visible for a second, but then it's gone now.
Now?
Okay, it's an embedded one. Okay.
Yeah.
Yes, sir. It's visible.
Thank you. I would like to request all of you to just have a look once again on this video. It's only a few seconds video. So it decides where to go. The data are all there. it senses whether it is a door or not. Then it decides, yes, it is a door. Then it starts making decision process that how to open this door, because there are so many doors, different types of door locks available, right? So it decides how to open this one and makes a decision making process and starts unlocking the door. Now, the last point here to be mentioned is that the first robot was not capable to make the decision that I am able to go, this is the right decision that I have taken. So it communicates with the other robot that, see, I'm not able to open this door, or there is something else, there is a fault, or I'm not able to recognize the door. So the other one comes into the picture, it opens the door and allows so there is sentiment analysis also in between the robots, which we do not have perceived before. So this is the thing that I wanted to explain in this video. So my point of discussion here is, we can see that a robot dog, the first one, was unsure how to get past the door, or we can say obstacle in front of it. The helping robot walks in, opens the door, and steps aside to let the other robot inside, which that is what we have observed. This has been taken in from the Boston lab, but I have right now we're collaborating with them for some AI projects. But my point is not that. My point is they are smart. They both are smart. They both can take the decision. Now, the first one took the decision that, see, I cannot cross this obstacle, and it communicates with the second one. Second one comes, checks, analyzes the data in terms of image processing, in terms of lock, whatever parameters has been designed. Then it decides that, yes, I can open this door. And then it opens the door. First, it allows the first one to enter inside, and then it closes the door and go outside, right? So this is what is the description of the video. Now from this, what we have to understand is that the smart devices should be defined in such a way that they have the higher or much more reliable and available computing power. Simply having, we often say that, see, we have this much of configurations. I have a very high configuration of my device. The configuration is not that important point to be discussed about the smart devices. The important point is that how much computing power that device is having. So that is going to be an important part to be considered. Now, the second point, what I have to explain over here is without any human interaction. So if I talk about the previous video, the system is automated, the data are been automatically automated, they are been exchanged automatically, they take the decisions by themselves. So nowhere in the picture a kind of human intervention is there, or nowhere in the video the human interaction seems to be working, isn't it? So it's a completely fully, kind of, that is a door, that is dog and door concept. So there is no such human interaction. This is what I was trying to explain in the previous slides. So if this goes as it is, and if the industries or the AI paradigms go on increasing the smart devices in such a way that what it is today, then after some time, not very after a long time, very soon, we will be in the world of zero human interactive world. And that is really a serious concern. I will once again show you one very good example, and that will satisfy this statement. Before that, we also need to understand that a highly capable IoT environment is needed to avoid fault tolerance. These are the impairments, error tolerances, sensor failures, absurd data. Sometimes you have smart devices and you say that it's not working. Their sensors are failed. Sometimes maybe due to environmental factors, maybe due to microwave frequencies, maybe due to transmission impairments, due to so many issues, the device gets failed. And if the device gets failed, what will happen? What will happen to the data that has been generated or that has been processed during the destruction of that device? You may ask, you may answer, you may give the solution as a cloud as a solution. No, I'm talking about the interconnecting the IoT devices, smart devices, right? When they are in the state of intercommunication, IPC, or let us say intercommunication process, and during that intercommunication process, if the communication breaks down, or there is a fault, or there is some other, distractions kind of thing, then what will happen to the data? And as I said, since data is fuel, and in that scenario, if data is been lost, what will happen to the next transaction or next phase of a device, state of device? So we have to have availability and reliability of smart devices. So this is the thing. And here, one thing that I would like to add is, can we add sentiments into the smart devices? I don't know how much of you agree with this. Sentiments may be anything, and honesty is also a part of sentiment. So the dog, the robot that have been shown in the previous video, can we apply sentiment to them? Can we apply behavioral kind of data to them? If yes, if we can apply, let us say we are capable enough to apply sentiment and behavioral data to those robots, then where will we stand? Let us have a look on this video. I'm sorry, this is not working. There's some issues, I think. Yeah. Yeah, it's not working. Now see, there is a human intervention. A person is coming there and the robot is dedicated. It has given a sentimental and behavioral data. It is now sentimentally strong, behaviorally it's strong, and it's dedicated. It has been asked to, it has the task of this robot dog is to open the door and see what will happen. Now, determination is been added to that smart device. This is what, see how the transformation of machine has come to the state of determination. The machine, the robot is itself a machine, isn't it? And the machine is now determined machine. Apart from taking inputs and giving out the output, it is also blended with sentiment, like determination. It is determined. It has to cross the door. So this is what is Industry 4.0. So these all I have explained, and I think Madam had instructed me to complete within 50 minutes. So these are some of the, yes, ma'am.
No, sir. I mean, if there are a few points, important points left, you can continue for a few
Sure.
minutes more.
Sure. Thank you. So there are one point that I would like to explain from here is, if you're out of station and want to monitor your smart farmhouse, I'm talking about the last point, this one. So if you're out of station and if you want to monitor your smart farmhouse, this can be easily done by smartphone. So there are various ways to do that. Various apps are there. You can download them and you can use your smart device on your doors, and from remote station you can check whether your house is locked or not, or someone is trying to intrude into your house or not. So this is what Industry 4.0 is doing on behalf of smart technologies. But of course, there are some disadvantages that we have to understand. The use and rapid increment in the number of devices. This is one of the biggest disadvantages and challenges we are going to face, because even you can see that there are so many different mobile phones coming into the market. They are so sophisticated, but we never, as a user, consumer, we never try to realize that what difference they have done inside that, the device itself. So basically, they incorporate a large number of devices in such a way that the machine gives the output at its perfection. Secondly, the large number of devices connected through the network increase the complexity of the network. Sometimes, even when you enter into the mall, or when you are in a very congested area, and everyone is trying to access the network, especially a common network, sometimes it gets jammed. It gets, your network performance is very, very poor. What happens there is that there is a kind of congestion problem, or even specifically, if I should say, it's a bottleneck problem. I'm sorry, it's a bottleneck problem. Something like, when you have a full bottle, a bottle full of water, and if you try to turn it around by 180 degree and try to overflow the water, try to pour the water, the flow of water will not be consistent. So that is the issue that we are going to face. We are facing in the smart technologies. And apart from that, this privacy, security, and trust, this will remain until and unless the data is completely secured. And until and unless the data is not secured, the smart technology cannot be smarter. Right? And the hacking is going on. It will go on, and it will have to be, stopped. And for that, we need to have a secure data. So, sensor failure, battery optimization, data loss, network coverage. These are the technical aspects. I would like to skip this. And this digitization and auto manufacturing, this is what we have seen in the third revolution, which is continued in the fourth revolution as well. And this is the picture that is the story of the day. So see, we started with this culture, right? And today we are in this culture. Now there are huge changes in between these all, but the data is same. Let me repeat, we started from here and we are now at Industry 4.0 with all these things happening around us. But in between transition from this state to this state, what is intact is the data. Of course, data is increasing, no doubt. The more the population is, the more the data is, the more people are accessing the services, the data is getting in an increase. But ultimately, the core part of the data remains the same. So this is just an introduction. introduction. You can find it in Google. It was originated just recently in 2011, and I hope you all know about Alan Musk. So he's working hard on this. He's number one in today's time. So it was started from Germany, and initially it was been named an Industry 4.0. From there, we started considering the fourth revolution as industrial revolution. And because basically this technology refers to targets to made for me concept. That is made for you. Whatever you talk about, that is for you. Right. So these are four applicational components of Industry 4.0. So IoT, I have already discussed. Cyber physical systems, there are their internet services and smart factories. So this is what is the final illustration. I request all of you to just have a look on this one. And by saying that, I would like to conclude. I'm sorry. So this is the ultimate result of what if it goes like this, then you will be stick around with the particular number or particular machine, or you will feel fully dependent on the machine enabled services. So this is all what I have to say, and these are some of the references. So
on behalf of students, I would want to ask you a question before we wrap up the session.
Sure, ma'am.
If you permit. So, I mean, a lot of radical changes are happening in terms of technologies, and that too smart technology, be it Internet of Things or people or services, right? So, if we talk about the young students coming out of the college after doing their post graduations or graduations, do they need to look it as a challenge, or is it a kind of an opportunity for them, uh, having lots of technology out in the market, where in India, if we talk about India, which has got a little bit of less of uh, people who are tech savvy, so
Yes.
how do they need to prepare themselves for this industry 4.0, especially the young people who are going to come out after their graduations and after their studies?
Thank you, ma'am. And a very enthusiastic question. Must be from a very enthusiastic learner, I believe, because it's a really a difficult question to be answered at this time when we are going through the smart
Lot of changes.
Yes, ma'am. So my answer will go in two ways. Number one, if you have to take it as a challenge in this way, like you are a very non-technical scholar, you have expertise in something like physics, mathematics, or some other commerce subjects or whatever, and you're completely non-technical, and you are acquainted with the day-to-day essential technological services only, like office systems, like how to operate mobile systems. These are not the services that I'm talking about in Industry 4.0. The service that I'm talking to, challenge that I'm talking in Industry 4.0 is when you get out of your UG program, you are certified engineer or graduate, and you go on into the corporate house, and they have incorporated their own e-system, electronic software system, on which you have to give the performance appraisal. Now, it is upon your skill and qualification how you go and adapt into that system. Now, that is on behalf of challenge I'm talking about. On the other side, it's an opportunity. There are so many courses going. There are so many things happening online. So you can go and adapt those courses. You can consult with the experts. You can consult with some of your seniors and choose your own topic of your interest and proceed ahead. So, ma'am, the answers will be two. One is you can take it as a challenge, or second, you can take it as an opportunity. Thank you.
Thank you so much. If any of the students have any thing to ask, please can go ahead.
Sir, may I ask a question? I have a small query. Okay.
Sure, ma'am.
Yeah, initially, good evening, sir. It's a pleasure to listen to you and understand so many things that is happening with 4.0. Being a first year student of MBA and planning to take HR as my specialization next year, I have a small query.
Yes,
if a student is planning to go into analytics,
okay,
and as we know, the HR scenario is changing from a traditional human resource to people are now looking at human capital with the analytical combination. So,
exactly,
which is the best language to learn in which coming 5 years, sustainability in terms of job, sustainability in terms of knowledge would be there? Because as we know, and as you explained, sir, data is a big asset. But once the data is used, it becomes redundant or secondary. So again, you have to keep on adding new data. So which is the best data language that an HR person should know?
Thank you, ma'am. Thank you for your question. And
My pleasure, sir.
And going for managerial point of view, of course, I said it's a data that is going to play as a fuel, and it is also true that once you use the data, it's gone. The relevance of the data is reduced. But the big data analytics, theoretically, I would suggest to go for big data analytics. There are so many areas for that. And when you talk about language, I will not, at this point of time, I will not suggest particularly X, Y, or Z language to go ahead, to proceed ahead for you, because you people are just stepped into the management programs and you are targeting a long way. So if you go, if you ask personally to me, then 10 years back, people were using Turbo C and C++, and they have been graduated and they were being placed in TCS and Infosys. Today, it is being done by second class, third class, or even seventh class standard students. Right? Seventh or sixth standard students are coding. So language is not that important. What actually important is the theoretical model structures that you are going to apply. Languages are thousands of languages available. It's your choice. It's your interest on which compiler you are comfortable with. The important thing is how you can play with the data, and for that you have to understand cloud computing and all. So I would like to suggest you to go with these theoretical subjects, and then accordingly you will find the right programming language. But otherwise, there are Python, Raspberry Pi is there as a tool. There are TensorFlow is there. So lots of languages are there you can go ahead with. But I wouldn't suggest X or Y or Z specified in a specified way. Thank you.
Yeah, thank you so much, sir. Definitely, you have helped me to answer a part of my question. If I go to see industries today with HR, they normally prefer advanced Excel, R programming, Python, and Tableau. Now, when you shared with me the point that there are thousands of languages available, you concentrate on the core of understanding. I agree. But still, sir, there has to be a specialization of a language or a two, which would give an added advantage to somebody who's doing MBA with a pre-industry experience.
Ma'am, you are targeting for HR? Are you going to
Yes,
go
sir.
for HR?
Yes, sir. Yes, sir.
And HR means human resource, exactly hiring and
Yes, sir.
retention
Yes,
of
sir.
humans.
Yes, sir.
Very good. So I would suggest you to go with R.
Okay. Thank you so much.
Blended with Excel, ma'am.
Advanced Excel, right, sir?
Yes.
Okay, fine. Thank you, sir. You answered my question now. Thank you.
Thank you, ma'am.
Thank you so much, sir, for taking up the questions, and wonderfully you have taken up these sessions. And I hope the students must have realized like how much is happening in terms of technology, and how much the fourth revolution of the industry had happened and brought about a lot of changes in the market. And there is always two sides of the coin. So it has got its advantages, and it does have a lot of privacy issues and security issues, but definitely there need to be a little bit of balance between human and technology. And thank you, sir, for sharing a lot of information on the subject. And though we are a little bit of ahead, I mean, we have taken a little bit of extra time. So events department would definitely consider that. And on behalf of Parallel University and Faculty of Management Studies, I would extend a very big thank you to you for sparing your time and talking about a lot of things that to current things happening in and around the industry. We hope to have you back in these kind of events, sir. Thank you so much. Have a good day, sir.